wanted to talk a little bit about some of the problems from chapter 11. Just a handful, as we have a lot of repetition in this chapter. The main goal here is to be able to, given a simulation, kind of like this one, create a simulation that's going to model our reality and give us the results using probability and the allocation of our digits and everything. So let's kind of get started. Number one, if you read the paragraph, it tells you that you're going to play a game and we want to be able to we're going to turn cards over, and we need to give these cards value. All right, so I chose 0 through 4. You could have chosen 1 through 5. It really doesn't matter as long as you give one net value in the ace and then 4 other numbers. And these are simply not aces. They don't even have to be real cards. So I've given my digits here, and there's a few things that I wanted to make sure to talk about as I'm giving the instructions to do the simulation. Number one, I needed to talk about repeats, because these are very specific cards. Once the card is turned over, it can no longer be turned over again. So repeats in this example are definitely not allowed. Skips, I'm definitely skipping values. In fact, I'm going to ignore every value from 5 to 9 when I go to my random number table. The trial is going to end when I find the ace, in this case, when I get the value of 0. I'm going to be recording, I'm going to be writing down at the end of every trial which event or which card I turned over to find the ace. Was it the first try, second try, third try, fourth try, fifth try? And we want to really know on which try I won the game. Eventually I'll get the ace even if it's on my last try. This has a little bit of an extra twist to it. Not only do you get the ace, but you also have a cash prize. So the $100 if you get it first, 50 if you get it second, 20, 10, and 5 if it's third, fourth, or fifth. And so we're going to make sure to note the turn on which we got the ace. Did that happen first, second, third, fourth, or fifth? And we're going to kind of match that up with the actual number value. Now, I'm not going to do all 10 trials. I don't want to bore you with all of that. But I'm going to do 2 trials just to kind of show you how I would use the random number table in practice. Hopefully, you've kind of already got this down, but we want to make sure that this is it's pretty solid, because this is one of the main ideas in Chapter 11. We did this with the Toy Story Lab, and I want to kind of bring it back here because this has a little bit more complexity to it, where I'm actually skipping numbers and avoiding repeated values. And so I'm going over here, I'm looking along here. 8 obviously is a number I'm going to skip. Then I have 3, right? That's a number I'm using. 5, not going to use that one. I'm going to skip that one. And 0, right? So I found my ace. My ace is always 0, so I'm going to write that down. I got 3, then 0, so clearly we found our ace on the second try. That's going to be equivalent to me winning a $50 prize, and so that's what I'm going to kind of write down. I'm going to go to trial 2. Now, I like to kind of continue on in the list as I go. I don't like to random just skip around. And so I'm going to start with not 0, but I'm going to start with the next number of 3, and then I'm going to kind of run down that list. And if I have a value that's 5 through 8, I'm going to skip over it. If I repeat a value, I'm going to skip over it, right? So here we have a 3, 5 I'm going to skip, 1's okay, 6, both of these 6s are outside of my range. There's my 2. I've already got 2 down. I've already got 1 down. 6 is out of range. I've already done 3, so I'm going to skip it. 6, 8, 1, 9, 2, 8. Okay, here's my first 4, right? So I had to skip all these numbers, right? And now there's only one left. I'm looking for the 0, so I'm going to kind of go along the lines because I'm going to skip every other, and there's my 0. So I'm going to stop right here at the 0. And these I'm marking off in red a value that either I'm skipping because it's already been used or it's outside my range. And you can see here I stopped at 0. Normally I kind of make a big line right there at the edge, so I know that my trial ended here and I can start back right at the end of that, so I don't get confused about that. So I do tend to make my values a little clearer. In fact, on the test or quiz, I do actually expect you to kind of write through this. Hopefully you're not having to skip as many numbers as I did this time. But now I only did 2 trials, but let's assume that I went through all 10 trials and I wrote down everything. And at the end, I'm going to write down my summary of what's actually happened. After 10 trials, we got an average payout of $39 for the game played in the music store. Always remember to put in in context, right, the average payout for the game or whatever in your conclusion. It's not good enough for you to simply say $39 or 38 or 42 or 49 or whatever you happen to get. It's really important that you talk about that, putting the answer back into context inside the question, right? And I could even add this better payout of $39 in the music store game, right? I would definitely want to make sure to talk about those things in context. I hope this really helps out in this particular question. A lot of people starting off had a little bit of a challenge. I want to go ahead and look at the next question. Now, this is number 31. This is the one we kind of assigned for homework. Let's check that out now. In question 31, you have a different setup, and I kind of want to just walk you through what I did to solve this question. Number one, I'm going to let my digits, I'm going to let the evens be the boys and the girls be the odds. And you could have reversed that. You could have said, I'm just going to use zeros and ones. I was using a standard number table to do this, so I really didn't want to skip any numbers. Now, if I'm using the calculator, I have a distinct advantage there because I can tell the calculator only use zeros and ones, and I don't have to really worry about skipping. Skipping is not a bad thing, but in a number table, skipping lots of things tends to make your problem very tedious. So if you're going to be using a number table, it's a really good idea. It's a very efficient way to use your numbers. So I didn't even use one whole row to do this. I really want to try to use up my numbers. So I decided to go with evens and odds, right? So repetition is okay here. I'm expecting to get repeated values. So getting that boy or girl is not, it's a generic response. It's not like a specific person. And so I'm able to do this in this case. My questions here, repeats are definitely allowed. You're going to have more than one of each type of kid possibly. So not a big deal there. I did not skip anything. You may have skipped something, and that's okay, as long as 50% of your responses were boys and 50% were girls. Next, we had to go in and kind of write down when our trial is going to end. We were going to end once the family had one boy and one girl. And so the total number of children really was what I was really looking for. You know, we're finding the total number of kids. They said family, how big would the average family size be? I think what they were really inferring was how many kids you're going to have. If you added the 2 adults into this too, that's totally okay. Your answer would have been 2 more than mine. I didn't add that in. And I just kind of worked through here. I started right here at the first row, and I simply just walked through each one of these values, right? So T1, I got an 8, then a 3. Here we go, running through here like this. Not a big deal. I started here, I got an even number and then an odd, and I stopped. So 2 kids, right? So you see I'm writing in the results. I went through each of these values, and I kind of went through 1 through 10 and just finished it out. At the end, I averaged my results. I had a total of 28, and I did divide that by 10 to get 2.8 kids. And here at the end, we expect to have 2 to 3 kids total. Now, I wrote my average down, so me rounding or estimating that to a more realistic scenario is totally okay. Now, if I hadn't written this down, I would have wanted to write that in my solution at some point. But I know that you can't have 2.8 kids, and I don't want to make it sound like you're going to have exactly 2.8. That doesn't happen. We know that's not possible. As long as your average value is written in your problem, you can tend to round to a more realistic answer between 2 to 3 kids. Obviously, you would either have 2 or 3. And it's really, these are estimated values. Someone else doing this exact same problem, you may have gotten 3.5, right? My average is just good for my numbers. And truly, the true average, by the way, is 3. So if you got exactly 3, you're out on the money. If you're close to 3, kind of like I was, it's a good thing too, right? And so a realistic answer is kind of nice. But if you also said you'd expect to have around 2.8 kids instead of the 2 to 3 kids, that's also a good thing too. I hope this helped out. I hope this simulation thing, you've got this down. and we're going to move on to the next subject tomorrow.